The question says that for the traveling harmonic wave yxt equals to 2 cos pi 10t minus 0.0080 x plus 0.5, where x and y are in centimeter and t is in seconds. Calculate the phase difference between two oscillatory motion of 2 points separated by a distance of 4 meter, 0.5 meter, lambda by 2 and 3 lambda by 4. Now for calculation of phase difference, the phase difference between 2 points separated by a distance delta x is given by, phase difference would be given by k delta x. Now in this equation, k is the, so we know from the wave equation that k is the coefficient of x. Now in this equation the coefficient of x is 0.00x0, so k would be equal to 2 pi multiplied by 0.0080 centimeter. So in meter it would be equal to 2 pi times 0.8 meter per meter. Okay. Now we have to calculate the phase difference. So for calculation of phase difference we will use this formula. Now in the case of A, we have 4 meter, delta x as 4 meter, so phase difference would be equal to k times, that is 2 pi into 0.8 per meter times 4 meter, so it would be equal to 6.4 pi per meter. Now the second question is, sorry, it should be equal to radians, pi radians. Now in question B, we have a delta x as equals to 0.5 meters, so delta phi would be equal to 2 pi times 0.8 multiplied by 0.5 radians. Now that would be equal to 0.8 radians. Now in question number C, we have lambda by 2. So we know by the definition of k that k is equals to 2 pi by lambda. So this is in the form of wavelength, so we will take it in the form of wavelength. Now delta phi for this would be delta x times k. Now that would be equal to lambda by 2 multiplied by 2 pi by lambda, so it would be equal to pi radians. Now the fourth question is D, delta x is equals to 3 lambda by 4. Now for this calculation of delta phi, it would be equal to delta x times k. Now k is lambda 2 pi by lambda, now multiplied by 3 lambda by 4, so the answer would be 3 pi by 2 radians. Thank you.